Hello everyone, in this tutorial we will create the motorbike with vehicle movement component. This motorbike will have the working suspension system, spinning chain, and we will create the control rig for our character to have the proper hand and foot placement. Before we can create this motorbike, we need to add a drivable vehicle to game animation sample, so you can follow along with this tutorial. After we have the vehicle that we can enter and then drive and exit the vehicle, we can add the motorbike to this system. I get this 3D model of the motorbike from Mr. M. And this motorbike license is Creative Commons attribution, so you can use it in your commercial project or your personal project. You need to give credit to the artist of this motorbike. So I rig this motorbike, and you can download this project. Link is in the description below. This 3D model. And we have the animation, driving animation of the character with default mannequin skeleton and UEFN skeleton. And this is the texture you can download. Let's open our project, game animation sample. From our previous project, we have this vehicle that we can drive and exit by press F. Add another folder, name it Motorbike, and then we import this SM mean static mesh. So we import the static mesh first. Then select the skeleton and choose import static meshes. Click import. Next, we need to import the skeleton mesh of the motorbike. And we don't have the skeleton. So when it import, it will import the skeleton bone. And it create a physics asset. Create a folder, name it materials, and we move this material inside material folder. Add another folder. This folder name is textures, and we need to import textures to this folder. Next, we need to import the animation. Go to animation, SK mannequin, sequence, and choose the skeleton, SK mannequin, and import. I create this animation inside Unreal Engine using Control Rig. I will put the link to the tutorial if you would like to create this animation yourself. And then import another animation. Choose SKUEFN mannequin, import. And save all. Next, we need to set up this material. Blend 10 SG. We delete this. Go to texture. By higher back tire, base color. This is base color. Metallic. Normal. Roughness. And apply this. To the next material. 11 SG. This is texture is higher low back part base color. Metallic. We have opacity. This is roughness. And normal. And we also have emissive. Apply. The next material. Well, SG. Go to textures. By higher front part base color. This one. Emissive. Metallic. This is normal. And we have roughness. Apply. Text SG. Textures. This by higher low front base color. tallness, roughness, emissive, and normal. Apply. When SG, texture, this is the base color, emissive, tallness, roughness, normal. Then apply. HSG, like this. Bike higher, low, body bottom. This is normal and roughness. Like this. 9SG, texture, bike higher, low, front tire. Apply. And the next is paint material. We can change this metallic to 1. Roughness, smoother is 0.35. And we can apply this and rename it to M paint. We can close all of this material. Save all. And when we go to this motorbike static mesh and this skeleton mesh, we have the material correctly applied at this mesh. But this windshield, we have incorrect material because we need the opacity for this windshield to be transparent. So go to material and this material 6SG, we duplicate and name this 6SG1. And we need the opacity of this material. Next to opacity, set to translucent. We should set it to side because our windshield have one direction mesh. And this volume metric set to surface translucency volume to have all the metallic roughness and emissive. Apply and save. And when we go back to this windshield static mesh, we need to change the material. And it's working. Next, for this chain, we can see the collision, simple collision. So let's remove this collision and add box simplified collision to this. We're going to use this length of this box for our calculation for the chain movement. Go to physics asset, and we have this physics asset that is very messy. Let's show constraint, show all bone, and we select all of this and delete all the collision. Next, we select on root, press Ctrl on your keyboard, and select physics wheel B and physics wheel F. Right click, create body with sphere. After we get this physics will be that full scale. So primitive, and select on the sphere to scale. We move it to the center first. And the same as the sphere, it already have the center. So we need to scale this up. To the side of our wheel. This is the sphere collision. And this root sphere, let's change it to box and then generate again to create root box instead. Scale this up and scale this. Shape of rectangle. And move it up. Next is this constraint. The root is physics type is default, and physics will be physics type kinematic, and this will F physics type is kinematic. So when we have kinematic, it rotates with the skeleton. And we have the correct angular limit. It is free for swing 1, swing 2, twist motion. The same with the back wheel. Save, close it. Now we create the vehicle blueprint. We call template, blueprint, and this BPP vehicle, right click, we create child blueprint class. Name it BPK Motorbike. And we can move it to another folder, Motorbike folder. Then open this blueprint. And we need the mesh. First, let's add the static mesh. This motorbike. And drag all of this. The body, wheel, and windshield. The back wheel parent socket is physics wheel. We need to change this mesh from SKM Sport to this SKM Motorbike. And this back wheel choose physics wheel back. And this one choose physics wheel front. And we change this camera. It is too far, so change this back spring arm. Target arm length is 380. And socket offset Z is 80. Next, we need to change this box position to enter this vehicle area. So 150, and this one is 100. Z is 50. And move it up 65 high. And save. We need to change this driver location and exit location. So the driver will sit on this motorbike. Location X-3. Z is 95. And the exit location, we can change Y to minus 140. We can move this vehicle to the right and drag this motorbike blueprint and set this Z to 0 to the center 0. Next, we need to create the animation blueprint of this motorbike. But this animation blueprint we create from blueprint class. The class is vehicle animation instance. Create. Name it to ABP motorbike. Because when we create this, we have the blueprint that related to the vehicle that can control the wheel of the vehicle. And click yes. Choose the skeleton. Our motorbike. This SKM motorbike skeleton. Okay. Go to motorbike blueprint. Off-road car. Go to off-road car, wheel front and wheel rear. Copy and paste it inside this motorbike. Rename it to motorbike wheel front. And this one is motorbike wheel rear. Open this wheel front. We change this wheel radius to our side of the wheel of our motorbike. It is 29. This wheel width can use 20. Wheel mass 10. And this friction force 4. Effect by brake is true. Effect by engine, it false because the front wheel don't have the engine attached to it. And we use ABS brake and set this max spin rotation 5. And we set the max steer angle 50 and affect by steering. Next is suspension. We use the up suspension -1 because when we tilt the suspension, the vehicle will bounce. So we will use the control lever to adjust the suspension motion. Suspension make rest is 8 and make drop 4. Spring rate 150. Spring preload is 0. We don't need this roll bar scaling for anti-rolling effect 0. And we use spear cast. For sweep type is simple sweep. Max brake 1500 and brake cost 3000. and wheel rear, it's a little bit larger radius than the front wheel, is 30, and this is width. We can change to, we can use 20, and the wheel mass is 10. This friction force multiplier use 8 because the rear wheel will have the friction more than the front wheel. And next is the suspension. Make right is 5, make drop is 5. Spring rate 150, and this spring preload is 0. Roll bar scaling 0, and this use shape cast. For brake is 500 and 1000. Save this. Now we go to vehicle movement component, and then we need to change the wheel. This mesh. First we change this animation blueprint because we still use the car animation blueprint. To motorbike, this ABP motorbike, set this. Next we change the wheel. We have 4 wheels for the car, so we delete all of this and add 2 more wheels. And we disable this legacy wheel friction position. For the bolt name, let's go to this mesh and we open the skeleton. And we change this wheel to the new wheel, this motorbike wheel front, and bolt name. Another one is rear wheel of the motorbike, and we need to copy physics wheel B, copy bolt name, paste it. Next is the collision of this wheel, because this wheel we have the collision, so it affects with the physics asset, causing the vehicle to fly away because of the physics conflict. Let's go to collision and set no collision for front wheel and back wheel. And we go to motorbike, this ABP motorbike, create mesh, space, ref host, wheel control for wheel vehicle. connect to the output port. This wheel controller, we can create it because our animation blueprint parent is vehicle animation instance. So if you have different parent, you cannot create this wheel controller. So we compile and let's play. And we have F, press F, and our character have the wrong animation of driving this vehicle. Next, we create animation montage from this retarget animation. Create any montage and open this animation montage. This is in and is blend out. Let's set it to 0. Blend time, both of it. And change this default, select to default to loop again this animation montage. We can go to BPP vehicle, event graph, and we can see that this begin overlap box on overlap vehicle. We don't know if this vehicle is motorbike or car. So we need to add another boolean to this function. Double click on this. Go to BPI, vehicle interaction on overlap vehicle. This input, we need to change it to is motorbike and save this. And we copy this into the child of this vehicle blueprint. Go to motorbike, BPI, BP, P vehicle, and paste this. So this is true, is motorbike, because we call it from this BPP motorbike. And this P vehicle, which is the parent blueprint, we delete this. Next, we go to off-road car. And we can paste this. And we set this to false because it's motorbike. This is the car. Sport car. Go to blueprint. And paste it here. Its motorbike is false. So when we call this, we know it is motorbike or car. So we use different animation for motorbike and another animation for car. Go to character blueprint, CBP sandbox character. And under here we have this event on overlap vehicle. Now we have the new boolean. So we promote this to variable is motorbike. Make space for this variable. For set actor location, we have different location for the motorbike. So each motorbike is true. We select vector and this one if it false. If it is true, we use the word location of driver location in component. Connect to new location. And another one is the animation montage. Is motorbike. Create a branch. If it's true, we play another animation montage. Let's copy this and choose the new animation montage of the motorbike. This one. And when it's true, when it's false, we play the drive car animation. And it should work for our character. Now we use ABP sandbox character. We want to use another animation blueprint because we will use different control rig to control our hand and the foot of the character to have the correct position on the motorbike. So we need to create another animation blueprint. Choose SKUEFN mannequin and create. Name it ABP sandbox character vehicle. This animation blueprint will use when our character drive the vehicle. Open. And we need the state machine and name this to idle state machine because it is just a simple idle animation. And open it. This entry, we add state. This state name is idle. Make this entry to this. And we need to choose the animation. Let's go to Asset Browser and search for idle. We can use this M neutral stand idle loop. Connect to this output. Back to anim graph. We call default slot. So this slot we can play the animation montage and connect to output post. Compile. And we have this idle animation. So go to CBP sandbox character. When we enter the vehicle, we change the animation instant. Get mesh. Set anim instant class. And move this. choose new class ABP sandbox character vehicle. So this animation blueprint is less complex than the motion matching animation blueprint. Next, go to BP vehicle. Before we set this name class to the character name class, but now we don't need to set this. We set it to empty class, and then this character name class is ABP sandbox character. So when we exit the vehicle, we switch to the animation blueprint for the motion matching of the character. And let's play. Press F. And now our character have the drive post of the motorbike. And when we press F again, exit, and we can drive the car with the correct animation. This BP vehicle, we can change this set actor location a little bit. This exit location. Because when the vehicle flip or it tilt, this exit location will be, sometimes it's under the vehicle, sometimes it's on top the vehicle or under the landscape, so the character will drop out of the map. So we use the vector, forward vector and right vector instead. Get actor location, add, this is the 86 and this one is 0. Get actor forward vector, multiply, and with this H and add to this. Get actor right vector, multiply, this is float, to y, and add with this forward vector. We can close all of these. Go to vehicle movement component. Now we will adjust the setting of this vehicle movement component. Scroll down. Go to mechanical setup, engine setup. So we go to sport car and copy this and paste it here in the motorbike and change the sport car to motorbike and set this torque external curve to this motorbike. This engine brake effect is 0.4 and roll down to differential setup and transmission setup. This final ratio is 3.08. We don't have the reverse gear for the motorbike, so delete it. And this change up RPM 4500. This gear change time 0.4 and this gear ratio we can change it to 3, 2, 1.55, 1.27 and 1. Steering setup into single and angle and vehicle setup. The mass from the mass of the car is 1500 to 300 for the motorbike. Enable center of mass override, so our vehicle don't fall down when we drive. It have the zero center of mass. Next is torque control. Enable rotation damping 15. Target rotation control. Enable roll vs speed enable and roll control scale is 1. Roll max angle 35. So this roll you can adjust it if you want the vehicle to tilt roll left stronger. You can adjust the angle to higher value like 45 or 40. Rotation stiffness 100. Rotation damping 10. Make acceleration 100. Auto center roll strength is 1. We want this roll, the vehicle to roll back to the center. And vehicle input advanced. This idle brake input 1. Brake input rate and handbrake input rate 10. For rate 14. And the same with handbrake 10 and 14. Compile. Let's change this SM motorbike body. Change the mass to 0. This will be to 0. wheel F to 0, and we forget the windshield, so add the windshield. This mass is 0. This windshield location. And now let's play. And we enter this vehicle. And we can drive this. You can see the front wheel is really strange. It turned incorrectly from the handle because we still don't have the control rig to control the handle of the vehicle. And we need to change this front wheel parent socket to wheel F. So the actual physics is in physics wheel and the front wheel attached to the wheel F. Now we can drive this motorbike, but our vehicle don't have the suspension working and the character don't turn the handle of the motorbike. In the next tutorial, we will create the control rig to control this. Thank you very much for watching. If you like this tutorial, please hit like and subscribe to my YouTube channel. Thank you very much for my patrons member who are supporting me. Your support really means a lot to me. See you in the next part of this tutorial.